Okay, so let's make a circuit where the resistors are in combinations of being in series and in parallel. So let's say that we have a voltage, V naught, and a resistor here with resistance R naught. And then here we will allow two paths, and we'll put resistors here with the same values, R naught and R naught, so all the resistors have the same value, but here they're in parallel. And then we'll just come back around here, and that's our circuit. So let's find first the equivalent resistance of the circuit. So how do we get the equivalent resistance of the circuit? Well, there's some equivalent resistance here, which then would be in series with this one. And so we would have R naught plus whatever the equivalent resistance of this is as the total equivalent resistance, or as the equivalent resistance. But what is the equivalent resistance of these? Well, they're in parallel, so we can have 1 over the resistance, where R is the equivalent resistance of this part. That is going to be given by that, and that is 2 over R naught. And so this gives us that the equivalent resistance R is half. Right? Once you allow the current to choose between these two paths, actually it should be clear that there's a symmetry here, so the current will be exactly half through one and half through the other, but that makes the net resistance half of the value of each of these. So we have an R naught over 2, and so the equivalent resistance of the circuit is therefore R naught plus R naught over 2, and that's 3 R naught over 2. Now let's think of the total current, and by that we mean the current that goes through here, I total, and the current through here, I total. What's that? Well, we need the voltage here and the R equivalent. So if Ohm's law is obeyed, which we assume, then we get V naught over the equivalent resistance of the circuit, which is this, which is 3 R naught over 2. And so we get, that's the total current. And now we're going to break this up into 2 here. Let's see that that's in fact the case. What is the current? Find the current through each of these. Let's call it I parallel. The current there is, let's again assume that through each resistor obeys Ohm's law. So we have voltage divided by resistance. The resistance is R naught. But what's the voltage through here? Well, when we come across here, we have V naught, and so we come all the way around here on this path through this resistor and back, that has to be equal to V naught. So we have V naught, but we have to subtract the voltage across here. So if Ohm's law is obeyed there, what's the voltage across there? So we're subtracting 2 V naught over 3 R naught times R naught. All right, that's Ohm's law applied to this. And we can, so in other words, the voltage across here plus the voltage across here has to add up to V naught. And so we have to subtract the voltage across here from V naught to get the voltage across here, and then divide that by the resistance here, that's R naught, and so we get V naught minus 2 V naught over 3 over R naught, which is V naught over 3 R naught. And so that's the current through here, and so we can see that that is exactly half of the total current. Right? Total current is twice this value, and so that all hangs together.